Hi, this is Craig Stocks. I'm here for Utah Desert Remote Observatories. You can find us online at utahdesertremote.com, and we would love to talk to you about hosting your telescope remotely under our dark skies in southwest Utah. If you're not interested in hosting, we also can provide hourly rentals of our telescopes. We have both a long focal length and a wide field. Wide field's a Takahashi FSQ 106. The longer focal length is a plane wave CDK 12.5. Both are equipped with the ASI 6200 64 megapixel cameras, and those are available to rent by the imaging hour. What I want to talk about today is color mapping of nebulae, and let's start by looking at these four versions of the Tadpoles nebula. Now, even though these look quite a bit different, all four of these would be technically considered an SHO color palette, where sulfur is mapped to red, oxygen is mapped to blue, and hydrogen is mapped to green, or maybe more accurately, somewhere between pure red and pure blue. And it's that variation in the hydrogen in how red or how blue you choose to make it and how much you want the green to show through that can lead to all these different variations. And the variations are useful both artistically to create a striking image that's interesting to look at. It's also useful if you're wanting to show different structures of gas within the nebula. Often you need color contrast to show the differences between one gas and another. And because, in particular, sulfur and hydrogen are very close to the same color, a natural color image just doesn't show that. So it depends a little bit on what you're trying to show in terms of information about the nebula. If you're wanting to show the relative concentrations of how much hydrogen versus how much oxygen versus how much sulfur, then this color mapping isn't very good, because this color mapping depends on kind of normalizing each one of the three to kind of comparable levels of brightness, even though they're not naturally the same brightness. And that's how you create the varying color contrasts. And one thing I will say, the version here in the top left, this one is actually a blend of the two on the right, kind of taking what I felt were the more interesting features of the two and blending them together. So it's still an SHO image, but it's using different combinations of SHO in different parts of the image. So let's talk a little bit about how I collected the data, how I processed the data in PixInsight, and then how I do the color mapping in Photoshop. And this isn't intended so much as a tutorial that you can follow along step by step, more demonstration of some of the concepts and the concepts of the way I use Photoshop, and maybe even more hopefully to generate some discussion and conversation about color mapping and how you like to use it in your images. So let's jump into PixInsight. And basically the data comes from the plane wave CDK 12.5, and it's around 15 to 20 frames each of sulfur, hydrogen, and oxygen, and then about 6 frames each of RGB. And generally that's normal for me. I use RGB for the stars, and a lot of times also just as kind of a reference image. What you see here, the three images that are up on the screen, these are kind of the processed narrowband image. So this would be the sulfur, for instance, and it's already been, I've run it through DBE to remove any gradients, did a stretch on it, ran noise exterminator and star exterminator to get a kind of a clean, what I would call normalized sulfur. Same with the oxygen and the hydrogen. And the Tadpoles is real nice because it's fairly rich in all three gases, and that gives you lots of room to play with different combinations. Now, just for comparison, I used the same data before I did any stretching, so that it was just the stacked data straight out of PixInsight. And I did a channel combination on those, and what you see is it's very much dominated by the hydrogen. Hydrogen has a a much stronger signal. Now again, this has been, after it was combined, it was stretched, and then I ran noise exterminator and star exterminator. But you can still see that it's a very green image, and that's because hydrogen is a much stronger signal in most nebula than the oxygen or sulfur. I mean, the others are there, they're just not as strong. And you can see some yellow coming through here from the sulfur and some blue showing through here from the oxygen. And just for comparison, if we take these three that have already been somewhat normalized, if we do a channel combination on these three, and I'll just pull up channel combination and drag each one. This is hydrogen, so we'll put it here in the center. We'll grab the oxygen, drop it into the blue, and grab sulfur and put it into the red. So when we combine this, we will get an SHO color palette. Apply. And you can see it's still somewhat greenish, but it's more colorful. It has more of the three colors represented. And in fact, with a little bit of work, you can start to turn this into a more interesting image. For instance, if we just pull up curves and get a preview here, we might, for instance, add a little bit more saturation. We might go to the RGB curve and add a little bit more contrast, especially brightening up the background area. Maybe something like that. That starts to give us a more, I'll go ahead and apply that, a more interesting image to look at with more separation between the different gases, and comparing that to the combining them unstretched. It's much more monochromatic. It tends to be all kind of the same color with just different shades of green, and not very interesting. So the difference here, this was combined and then stretched. This was stretched and then, so it was somewhat normalized and then combined. Now, just for reference, I also did an RGB version. So this is the RGB data that was not only normalized, it was run through the new spectrometric color calibration process to get as accurate a colors as I could out of the RGB data. And then from that, I extracted the stars. So that gives me the stars to use as a separate layer. Generally, this is about where I would stop in PixInsight. And the things I would use from PixInsight are the stars in color and these three monochrome, sulfur, hydrogen, and oxygen. And I would load those four things into Photoshop. So let's hop over to Photoshop and explore that process a little bit. So here's kind of a finished version of the image, and I find that every time I process the same data, I will get a different result, just depending on kind of my mood, or some little difference in where I start will lead me to a different finishing point. But in this case, this is where I ended up in Photoshop. I wouldn't consider this a finished image yet, but it's kind of where I left off. And so we can go to this version, which is that same photo, but with all of the changes undone. So it's just the basic stars and the other layers. So if we look over on the right-hand side in the layer palette, these are the pieces that I loaded in from PixInsight and then organized into, in some cases, layer groups. So if we turn the stars off, this bottom layer is the RGB data with the stars removed. So that's just kind of basic RGB from PixInsight. And then I also brought in, just for reference, this the very green version of the SHO channel combination, just as a reference. And then I have 3 layer groups, and each layer group has the monochrome data for sulfur, oxygen, and hydrogen. And the reason I put them in layer groups is so that I can add things like a levels adjustment layer on top of the data, so I can individually brighten and darken the different pieces of sulfur, oxygen, and hydrogen to combine them and color map them. So that's the sulfur, there's the oxygen, there's the hydrogen, and then lastly on top we have the stars. And in the new Star Exterminator version, it has the option to unscreen the stars to create an unscreened mathematical process of separating the stars from the background. And what that lets you do if you're using Photoshop is you put those stars on top, and again they're in a layer group, but you put that either the layer, or if it's in a layer group, you put the group into the screen blending mode, and then that puts the stars back the same way they were taken out. Now, one caveat to that is they were taken out of an RGB image and you're going to put them back into a narrowband image. So there are likely going to be some color shifts just because of the way the screen function works, because you subtracted it from red and you're adding it back to maybe a green or a blue color. But it still is a pretty accurate way to go. So let's talk a little bit about color mapping. And to do that, I want to jump over to this blank document that's very uninteresting. It's just 3 circles, a red one, a green one, and a blue one. And you've probably seen demonstrations like this where the colors overlap. And where the colors overlap and you have equal amounts of red, green, and blue, you wind up with a neutral color, either gray, light gray, white, something with no color to it. Now, I have each one of these 3 circles. The red is on a red layer, the green is on a layer labeled green, and blue is on a layer labeled blue. And if we use the inspection palette, and if you watch the numbers up here in the top left of this palette, it will show the values of red, green, and blue as I move the color picker across here. And you can see, for instance, if we look at the red, the color there is actually 128 red, 0 green, and 0 blue. And just as an aside, 0 green and 0 blue doesn't mean it's not contributing any green or any blue. It means it's contributing 0 green and 0 blue, which would be considered black in that color palette. So this is just a medium red, 128 red, no green component, no blue component, or I should maybe properly say the green and blue components are black. If we look at the green circle, just as you would expect, it's 0 red, 0 blue, and 128 green. You're probably way ahead of me. The blue is going to be 0, 0, 128, so it's all blue, no red or green. Now, because these are in normal blending mode, and we're contributing all 3 channels from each one of these, the red, for instance, is on top of green and blue, so it completely covers up whatever's below it. And this is where having these in the red, having 0 green and 0 blue, is important, because in normal blending mode, those zeros replace what was below. Now, in fact, each one of these images, each one of these layers is an RGB image, and it has all 3 colors. We've seen the colors up here in the color palette. If we can turn individual pieces on and off, then we can blend colors differently. So let's start with the red since it's on top. And there's a couple ways to get to it. I can go to Layer, Blending Options, under Layer Style, Blending Options, and that will bring up this dialog box. And if it's an RGB image, in the center you'll have this channels and then a checkbox for red, green, and blue. And what that's telling us is that each one of these channels is in effect turned on this layer and is contributing. So we know that the red is 128, green is 0, but it's contributing zeros, not nothing. And blue is likewise contributing zeros, not nothing. If I turn off green, watch what happens over here. If I turn off the green channel on this red layer, Now, rather than contributing 0, it's contributing nothing at all in the green channel, and that lets anything that's in the green channel below it show through. If I also turn off the blue, it does the same effect. So rather than zeros for green and blue in this area of the red layer, I now have nothing in the green and blue of this whole layer, and that lets the greens and blues below kind of shine through and create yellow and magenta, which magenta is red and blue, yellow is red and green. Let's click OK, and let me go to the green channel. We can do the same thing. If we want this channel to represent just green, we can turn off the red and the blue, and now we get cyan, which is the mixture of blue and green, but also notice in the center we get neutral gray, because now we have equal amounts of red, green, and blue. And if you look up here in the color palette, you can see that we are now getting red, green, and blue, all three in equal amounts. And the reason we're doing that is we're using just the red from the red channel, letting green and blue come through from below. In the green layer, we're taking just the green and letting the blue that's below come through. We didn't have to do anything to blue because it's at the bottom and it's still contributing all three colors, but the red and green that it contains are being replaced by these layers above it. So the green, for instance, that's on this layer is being replaced by the green on this layer, and the red is being replaced on this layer. So that's how these create these this kind of rainbow of colors, of all the different colors. So let's go back to this image and we'll do the same thing. We've got, I'll turn off the stars just for clarity. We've got sulfur at the bottom, and if we want this to be an SHO color palette, then we know we're going to let sulfur be red. If we go to our oxygen, well, let's just start with hydrogen since it's on top. We want hydrogen to be green. So if I double click, which is another way of getting to this blending options, by just double clicking on the layer or the layer group to the right of the name, here are the three channels. We want hydrogen to be green, so we'll turn off red and turn off blue. And now we have an image where we're getting green from the hydrogen, and we still have just the other channels from oxygen. So let's go to the oxygen layer. We want it to be blue, so we'll turn off red and green. And lo and behold, we now have a three-color image, even though each one of these images is monochrome. It's not truly monochrome, it's gray, meaning that it contains all three channels, red, green, and blue. It's just that red, green, and blue are equal in each one of them. So it was, kind of that easy to go from monochrome image to a full color image, and this is an SHO image, but we probably want to do some fine tuning. And there's a lot of different ways to fine tune this. That you remember, I put these in layer groups, and within those layer groups, I have a levels adjustment, and each one of these has been reset, so it's been zeroed. Let's start with the hydrogen, and if we just let's grab the rightmost slider first. If I pull it to the left, that's going to be brightening the green highlights. And then if I slide this back and forth, let me make sure I've got this. Maybe you caught this and I didn't, but notice I've got green and blue both checked. This should be just green. There we go. So now it's behaving appropriately, and as I slide the highlight slider or the midpoint slider, I can make that green brighter or darker, more prominent and have that green image, or less prominent and have a much more blue and red image, or somewhere in between. And by going to each one of these channels individually, I can really fine-tune the contribution. In this case, we're playing with the blue contribution of the oxygen channel. We can go to the sulfur and play with the contribution of red. And just by iteratively moving back and forth, using the sulfur channel for the red, the oxygen channel for blue, and then the hydrogen channel is our balance between red and blue. If we want more green, more red, or somewhere in between. So you can just kind of visually dial this back and forth to find a color combination that looks good, although in this case it looks a little flat. Now we can start adding some normal Photoshop type adjustment layers. And you'll notice I never flatten an image. In fact, I haven't even cropped out these where the frames didn't quite overlap from PixInsight. I just always keep everything the full frame and only crop when I am ready to create output, either for the web or for a print. So if I go to the hydrogen group and let's add a hue saturation adjustment layer, and we can play with the overall saturation. We can also play with the kind of that color balance by twirling. You can think of this as twirling the color wheel when we move this top slider. We can also grab individual colors. For instance, I could grab the red, and if I move it to the left, that will tend to make the reds more red and less orange. If I grab the yellows, I could make them more red or more green or somewhere in between. I can grab the cyans and make them more blue, more teal, make them more green. And basically what I'm doing is just working back and forth, trying to find combinations that give me good color contrast and also a pleasing color combination. And typically then I will go to a color balance at some point and work with kind of global red, green, and blue color balances to, again, continue fine-tuning. And notice how much more of the subtle detail here in the center is starting to come out as we find color balances that have more inherent color contrast and let us see details that were, kind of lost otherwise. And sometimes you can, because the layers are all still intact, you can go back and forth to the source layers as well as these adjustment layers. We may add another kind of a final levels adjustment to adjust the overall brightness. Let's say something like that. And then we can choose, do we want the stars included or not included? So with stars or starless. If I want to do a sharpening, which I probably do on this, what I would do is do a stamped layer, which Shift Control Alternate E on Windows, and that creates a stamped visible. And notice I've got the stars turned off because I don't want the stars in this sharpening layer. And then I'll desaturate this, take out all the color, and then just do a quick high pass sharpening and adjust as you adjust this high pass, there's kind of two places that are useful. One is to have a very large radius, and that gives you local contrast that's hard to produce just from curves. And let's just go ahead and commit this. And then you put this layer in soft light blending mode. And if we turn this on and off, you can see what it does is it adds dark to the darks and adds light to the lights and creates a little bit of that local contrast. The other thing we can do with that layer, and let's just go back in time and go back to the high pass filter, and usually somewhere in a very low setting, somewhere around 10, works really well for sharpening details. And again, we'll put that in either soft light or overlay blending mode. And there's nothing that says you can't use both mechanisms. That if I had made this a smart object, then I could work with these filters a little bit more interactively. But that's kind of an overview of my approach to color mapping. That by working with the individual sulfur, hydrogen, and oxygen and assigning color channels, or selectively turning off and on the various color channels, you can get just almost an infinite range of variations within for instance, an SHO color palette. And another nice thing about working in layers is, suppose we decide we want something completely different. So let's just turn off these adjustment layers. And let's say we want an OHS. So we'll put oxygen in red, hydrogen in green, and sulfur in blue. So hydrogen is going to stay where it is because it's already just green. If we go to our oxygen, and I'll double click, right now it's in blue. We'll change it to the red channel, turn it off in the blue channel, and we now have sulfur, if you remember, is contributing all three, but we're replacing the blue with oxygen and the green with hydrogen, and so now we have an OHS color palette. And if you want, you can just experiment with different color palettes and find what works well for you. So it's both artistic as well as there is some scientific value if you're able to differentiate between what gases are where. Although, because of all the differential stretching, you're not able to draw any conclusions about how much hydrogen versus how much oxygen versus how much sulfur. And most likely your star colors are going to be distorted because they were extracted from an RGB image and then overlaid onto a narrowband image, and some of those colors are going to show through and contaminate. So I hope you found this useful. If you have any questions, drop them in the comments below. I'll be happy to try to answer them. I know this was a bit long-winded, but hopefully this has given you good food for thought. And if you use Photoshop, hopefully it has given you some techniques you can explore. Be sure to check us out online at UtahDesertRemote.com. And I hope you have a great day today and an even better night tonight under clear, dark sky. Thanks.